Day 7 of 90. Today is a build day. We are writing a log file parser in Python that processes auth.log and syslog to find failed login attempts and flag suspicious source IPs. This pulls together the string manipulation from day 5 and the error handling from day 6 into a practical tool. Let us start with the core problem. When someone tries to SSH into a Linux server with the wrong password, sshd writes a line to auth.log that says failed password 4, followed by the username and source IP. If the username does not exist on the system, the format changes slightly to say failed password for invalid user first. Our regex needs to handle both cases. I use an optional capture group for the invalid user prefix, which lets one pattern match both formats. The regex also grabs the timestamp, hostname, source IP, and port number. Now I open the log file and iterate line by line. For each line that matches, I extract the captured groups and build a dictionary with the timestamp, host, username, source IP, port, a boolean for whether it was an invalid user attempt, and the line number for reference. One important detail: I open the file with errors set to replace. Production auth logs sometimes contain garbled bytes from malformed PAM messages, and you do not want your parser to crash halfway through a 500 megabyte file because of one bad character. Raw failure counts are just noise. A single password typo by a legitimate user generates a failure entry. What we actually care about is volume and velocity. I use Python's counter from the collections module to count failures per source IP. Any IP above a configurable threshold, say 15 failures, gets flagged as a brute force candidate. But counting total failures per IP is not the whole picture. I also compute the set of distinct usernames attempted from each flagged IP. This distinction matters for triage. An IP that failed 50 times against the root account is likely a targeted attack against a known privileged username. An IP that tried 50 different random usernames is almost certainly an automated credential stuffing bot running through a dictionary list. Different threat profile, different response playbook. The targeted attack warrants immediate password rotation, while the dictionary attack calls for IP blocking at the firewall. Auth.log only covers authentication. For a broader picture, I also parse Syslog. The approach is similar but more flexible. Instead of a fixed regex for one log format, I define a list of alert keywords like error, segfault, killer, refused connect, and link down. I compile them into a single alternation regex with re-ignore case, then scan each syslog line. When a keyword matches, I parse the standard syslog timestamp host service message format and store it as a structured alert. This gives you a secondary data source to cross-reference. If a brute force IP shows up at 314 and syslog has a refused connect at 315, that timeline correlation tells a story. The final piece is output. Parsing logs only matters if other tools or analysts can consume the results. I write a JSON report that includes a summary section with total failed SSH attempts, number of flagged IPs, and syslog alert count. Then the details, the full list of flagged brute force IPs with their attempt counts, the top 10 targeted user accounts, and the most recent syslog alerts. This JSON format feeds directly into Slack webhooks, Jira ticket creation APIs, or CM ingestion endpoints. During an incident response last year, I used a script just like this to process 6 months of auth.log from a compromised jump box and had answers in under a minute, faster than waiting for a CM import. That is the complete log parser. We covered regex pattern design for auth.log with the optional invalid user group, brute force detection with configurable thresholds and distinct username analysis for attack classification, syslog keyword scanning with compiled alternation patterns, and structured JSON report generation for downstream tooling integration. Each of these components is reusable. You can swap the regex for a different log format, adjust the threshold for your environment, or change the output to CSV if your team prefers spreadsheets. Tomorrow on day 8, we move to Python socket programming, which lets us build network-level tools to complement log-based detection with active probing. See you then.